All right, so just to wrap up questions 9 and 10, these are very easy, but make sure that we run over it so that you have a rough idea of really what's going on before we jump into W5-2, page 1. All right, so we're still moving in a circle here. We're still doing that 20G centrifuge, that centrifuge from up above. So draw yourself a little circle. Then let's get our givens of units. What do we know? This is going back to the original question now. We're not talking about question 8 where we shifted to half radius. So the original question, the radius was 8.8 meters. We had determined that the average speed was 33 meters per second. If you don't recall, come up over here. Here it is. All right, cool. And we also knew about the 36 revolutions per 60 seconds, and we'll see whether we need that. We knew from this then that the time for one revolution was 1.67 seconds. And finally here, the question is, calculate the magnitude of the centripetal acceleration. Now the word magnitude is here because acceleration is a vector. We don't want to worry about which way for this question, so we can discount the direction. We can ignore it with the word magnitude, which means don't worry about it on the answer. So AC, centripetal center-seeking acceleration, is what we're looking for. Acceleration, of course, comes in meters per second squared. Equation here. The equation is AC equals V squared over R. And since we already know that V is 33, we square that, put it over R, which is 8.8. You will get an answer of roughly 120 meters per second squared. So, running this in the calculator just for a moment, 33 squared divided 8.8. My calculator says 123.75. 120 is actually the correct answer because this is a 2 sig fig problem. So with 2 sig figs, as we entered over here, you want a 2 sig fig answer, we're good to go. 120 is actually the 2 sig fig answer. Finally, last question for you to worry about. What happens to the centripetal acceleration if speed is doubled? Now, of course, we got the brute force method. The brute force method, R is still 8.8. The V now is 66. The time we didn't need, AC is the question. And of course, you can run your numbers here. AC is V squared over R. Substitute and solve. AC is 66 squared over 8.8. And no, this does not give you double the acceleration. If you do 66 squared divided 8.8, you will get 495, or about 500 meters per second squared. Oh, fair bit different there. Now there is a finesse method for this. And so this is our second exposure to the finesse method this unit. The finesse method actually makes your life much easier. Knowing that AC is V squared over R, what we can instead do is plug in our multiples. Does V change? Yes, it does. How so? It doubles. So we put a 2 up there. That gets squared because there's a squared in the equation. Divide. Does the R change? No. So it's a multiple of 1. 2 squared over 1 is actually 4. Actually 4. And so this does not mean, even better put an arrow here. This does not mean that the new acceleration is 4. It means it is 4 times greater than the original AC. In this case, it would be 4 times 120. Or if you kept track of the greater sig figs, 4 times 124. Either way would be okay here. This one is going to give you 480, and this one is going to give you 496, which would be 500, what we got up over here. So again, that's a sig fig issue that I would not squeeze you on. If we were in more of a error analysis based course, we can squeeze you on that. But for now, that's it. So when you do your homework on the front of W52, you will find that this is pretty easy. You're just doing this equation, I believe, 4 or 5 times.